Hi guys, welcome to video 2 of the chapter 10 review, your test. We're starting with the free response problems on number 11. It says a rope is swinging in such a way that the length of the arc is decreasing geometrically. If the first arc is 18 feet long and the third arc is 8 feet long, what is the length of the second arc? So it's a geometric sequence here. We know it starts with 18. We got a blank, and then 8. So remember, for geometric, to get to each of these numbers, we multiply by our common ratio. So 18 times r is going to be equal to 8. So if I divide this by 18, I get r squared is equal to 8 over 18. When I reduce that fraction down, I get 4 over 9. And then I'll take the square root of both sides to find my common ratio, and that's 2/3. Now, they didn't ask me what the common ratio was. They said, what's the length of that second arc? So I'm going to take 18, multiply it by 2/3. This would be 36 over 3, which is 12. And so that is the length of the second arc. All right, number 12. They give us the 20th term and the 30th term. And you have to find the 51st term. This question is pretty in-depth and requires a couple of different moves to make it happen. So first of all, I need to note that it's arithmetic sequence. So I know I've got a common difference that I'm adding each time. So if I start at 132 and I put in my blanks, and then I get to 202, there's going to be 9 blanks in here. So this would be 21, 22, 23, all the way up to 30. And so what that means, because it's arithmetic, is 132. Each time I do one of those, that's going to be 10 times my common difference is going to be equal to 202. So if I take 132 and I add d to it 10 times, I'll get to 202. And so I'm going to solve this equation to come up with d. So subtracting 132, I get 10d is equal to 70. And so d is equal to 7. So I know my common difference is 7. Well, how does that help me? Not a whole lot, because I'm trying to find a sub 51. And so that's going to be a sub 1 plus my common difference, which I know now, 7 times 51 minus 1. That's great, but I don't know what a sub 1 is. So I'm actually going to have to use one of these two terms, and it doesn't matter which one you choose. Let's just use 20. I know a sub 20 is 132, and that's equal to my first term, which I do not know, plus my difference times 20 minus 1. And so I can use this equation to find my a sub 1, and then I can use that to plug in here. We know our difference already now is 7, so we're down to this equation. So 132 is equal to a sub 1. 20 minus 1 is 19, times 7 would be 133. Subtracting that guy off, I now know my first term is negative 1. And so now I know all of the puzzle pieces to find a sub 51. And so 5 minus 1, sorry, that should not be 5, Miss Harris. That should be 51 minus 1 would be 50, times 7 would be 350, minus 1 would be 349. So we know the 51st term of this sequence is 349. All right, number 13 asks us to write this series here in sigma notation. So sigma notation requires the big sigma. I'm going to make it from n equals 1. This guy goes dot, 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 so that means it's going on to infinity. And it looks like I've got 2/3 to the n power. Now, I know a lot of people say, would it be this, Miss Harris? And 2/3 times 2/3 to the n minus 1. Yes, that is absolutely the same. But notice if you've got 2/3 times 2/3 to the n minus 1, that 1, we would add our exponents. N minus 1 plus that 1 means it's just to the n power. You can see it written either way on a standardized test, so just make sure that you can recognize that. And how we got that is, this is my first term, is 2/3, then notice this guy is 2 squared over 3 squared 2 cubed over 3 cubed, 2 to the 4th over 3 to the 4th, so on and so forth. So that's a geometric series. It's an infinite series. Could we find that sum? You betcha, because this term here, my common ratio is less than 1. Remember, it has to be less than 1 in order to find the sum of it. Don't let that catch you tomorrow on your test. All right, find a sub 23 for this sequence here. So a sub 23 is just a matter of plugging in 23 for n. So 23 minus 1 would be 22 divided by 2. This is really 11 over 8 plus 11. Finding a common denominator would make this 88 over 8. Which means we got 99 over 8 would be my 23rd term. If you put that in decimal form, it's 12.375. Again, you might see it either way on a test. Number 15 says, write a recursive formula for the nth term of this following sequence. Remember, recursive formula always has to start with a sub 1. So my first term is 100. For each term that comes after it, it's geometric. So I'm going to be multiplying times something. I'm going to be multiplying the term that came before it times something. So what am I multiplying each term that follows by? For this one, if I notice, to find that r value, remember you take the second term divided by the term in front of it. So this would reduce down to 1/5. So I multiply each term that came before it by 1/5 to come up with the term. I'm saying that funky, but I hope you understand what I mean at this point. Sorry, it's a little crazy. All right, in a geometric sequence, the 9th term is 5 and the 14th term is 12/15. Determine the common ratio of the sequence. So 9 is 5, 10, 11, 12, 13, 14, hopefully my board picks back up. 14th is 12/15. So 5 times r times r times r times r times r. So 5 times r to the 5th is equal to 12/15. We want to solve this for our common ratio. R to the 5th, not r squared, this here. So r to the 5th is equal to 243. And now to get rid of that 5th, we're going to take the 5th root of both sides. And r is equal to 3. And that's what they asked us to find, which was the common ratio. You can check your work to make sure that's right. 5 times 3 is 15, times 3 is 45, times 3 I think is 105, or 35, times 3 would be 370 plus 3 405. Times 3 would be 12/15. So that works out. All right. So that's it for sequence and series. I'm going to do one last video on binomial expansions, and that is coming up next in part 3.